So, in the earlier lecture, I talked about non-inertial frame of reference. Now, today I will again talk about non-inertial frame of reference, but it is a rotating frame of reference. Non-inertial frame of reference. Here I will talk about rotating frame of reference. So before moving towards the lecture, let me first of all show you a video which I made. So yeah, this is a video. Let us have a look at it. Say this is so let me again say here this is a ball and ball is attached to a string, right? And this is very closer to it. So what I did, I started rotating this in a particular direction in this way, and what will happen, let us have a look at that. Just see. So I applied a force and it starts rotating with a constant velocity, and what will happen, it basically go straight, thread will go straight, because earlier it is like this, the ball is somewhere here, but now the ball is in this direction, right? So that means the ball moves radially outward from the center. It's a radial outward direction, means a force applied on the ball applies on the ball radially outward. So this force is known as a centrifugal force, and it is a fictitious force. So what causes this force? Because I am not moving a ball away from the center, but it automatically moves away from the center, and this force is applied by this fictitious force is applied on the ball by the rotating frame of reference, right? So then I did one more experiment. What was that? Let us have a look at that. Just see. So this is it. This is with this. Now I stopped it. So when I stopped it, it again goes in the initial direction. Means again force applied in the opposite direction. It goes towards the center now again, and there is this thread will get linked. Now I did one more experiment. So this is a let me again rewind it. So there is one more ball with me. I just put it on it and I just rotate it. Just see. It's a ball, means I thrown ball from my hand in this direction. So I have thrown the ball from my hand in this way. It will go like this. But when I started rotating it in this way, when I started rotating, means it is a moving ball. It is moving certain velocity and enters in a frame of reference, and that frame of reference is moving. Then what will happen? Let us have a look at that. So see what I did. It will go like this. It is rotating like this and it will go like this. So curvature in path, in the path of the ball, this is known as Coriolis force. So that means when a moving ball moving with certain velocity enters in a frame of reference, and that frame of reference is rotating, then another force is also acting there, and this force is also a fictitious force. So that means a rotating frame of reference applies two types of forces, and these two types of forces are fictitious forces. These are two fictitious forces, and when they applied on it, then what will happen? And these two forces are said to be, one is the centrifugal force and another is known as Coriolis force. So this is our experimental observation. We are assuming that the two types of forces are acting on the system. Now let us try to do mathematical derivation for this particular. So let us try to do the mathematics for this particular case. So there are two frames of references. So say this is x-axis, this is y-axis, and say this is z-axis, and suppose this is a stationary frame of reference and is represented by S. And when I try to look at a particle, there is a particle somewhere here, and say this particle is P. And let us suppose that its distance from the origin is basically r. So r vector in S frame is represented by xi cap plus yj cap and zk cap. Now what will happen? There is another frame of reference, and that frame of reference is moving with certain angular velocity. It's like this. Omega is the angular velocity. So let us try to represent that frame of reference and say this is another frame of reference. Say this is x prime and it is a y prime, and say it is a z prime. So the coordinates in one frame of reference is represented by like this, and its coordinates are represented by x prime, y prime and the z prime, but this distance from the origin will remain the same. So that means in the moving frame of reference, and say that moving frame of reference is represented by r frame, because it is rotating and it is rotating with the uniform velocity. Rotating with uniform velocity, this is rotating with the uniform velocities, and it is represented by x prime I cap, y prime j cap and z prime k cap. And as we know that these both the values will remain the same, so that means this r in S frame is equal to r vector in the R frame, because both will remain the same. But let us try to look at it mathematically. So this is represented by, this is basically represented by this x prime I cap plus y prime j cap and z prime k cap. But as I am interested to find out the force, so for force what I need the acceleration, and acceleration when gets multiplied we will get the force. So what should I do that? For that I have to take its derivative with respect to time. So that means I can say that this r vector in S frame is also equal to x prime I cap, y prime j cap and z prime k cap also. it's a primed summation, right? So let us take the derivative of both sides. So it is dr over dt in S frame is equal to, and what about its derivative? Since S frame rotates, so that means x prime is also changing and the I prime is also changing, or I cap prime, and similarly y and the j and the z and the k, these all are changing, as I have also discussed in the frame of references or the Cartesian coordinate system in the Galilean transformation. So that means this can be written as d upon dt x prime plus d upon dt y prime j cap d upon dt z and the k cap. It can be written like this. So what it will be? It is dx prime over dt I cap plus x prime d I cap over dt plus dy prime over dt plus j and it is y prime and the dj prime over dt plus dz prime over dt into k prime plus z prime d upon dt k prime. It can be written like this. Sorry, let me put it here. Yeah. So let us put dx prime over dt I cap, then dy prime over dt j cap plus dz prime over dt k prime. Let us put these together and after that put rest of the terms. So it can be written as x prime d I prime over dt plus y prime dj cap prime over dt plus z prime dk prime over dt. It can be put together. So dr upon dt in S frame, it can be written like this. So say something is related with the, because x prime and the change in I prime cap is basically related to angular velocity. So as we know that if we recall the expression for angular velocity, as we know that v is equal to omega cross r. V is basically omega cross r. So similarly di cap over dt, it represents the, it's equivalent to a unit vector changing its direction. So that means it is the change in the velocity in a way. So it can be written like this. It is omega, it can be written like this because it is dr upon dt. So if I try to look at this, so keeping this as a base, I can write down di prime by dt as the omega cross I cap. Similarly, dj cap over dt can be written as omega cross j cap prime, and dk prime over dt, it can be written as omega cross k cap. So how this can be written as this particular term? So that means this dr over dt in S frame, and say these are the primed, this is also prime, this is prime, this is prime, this is prime. So it can be written as d r over dt in rotating frame. It can be written like this, plus x prime omega cross I prime plus omega cross y prime is as it is. Yeah, let me, yeah. So this is basically equal to this one, and it is y prime, and it is omega cross j prime plus z prime plus omega cross k cap prime. Sorry, it is a multiplication. So what it will be, it can be written as dr over dt in r frame or the rotating frame. It can be written as omega cross xi cap plus or it can be simply written as like this, y prime j cap z prime k cap. So what does it mean? So it means that it is dr over dt in the rotating frame plus omega cross r, and it can be written as dr over dt because r in s frame is equal to r in rotating frame, both are equal to r. So simply let us write down it as a r, right? So this is the one relationship which we are getting. Or we can also say it is vs, velocity in the s frame, is equal to velocity in the r frame plus omega cross r. It can be written like this. So let us do little more algebra now. Let us suppose that let us use the concept of the dummy variable. Say if in place of r, as we are putting here, if we are having another vector, and say that vector is a p vector, so then this can be written, and this p vector, it is seen from the any frame of reference. It may be, or rather than p, let us call it as a q vector. So in place of r, if I put a q vector, then this relationship can be written like this: dq over dt in one frame of reference is equal to dq over dt in another frame of reference plus omega cross q, and q is any vector. As I want to move from the position to the velocity derivative, because velocity derivative is basically acceleration, so for that what should I do? I will use this dummy variable concept. So keeping this formula in mind, I simply replace this q with the what? It is the velocity of the particle. I just simply put the velocity. So what should I do? I simply write down these two here. So what should I write? According to this, I can write down as a dvs over dt in s frame is equal to dvs over dt in r frame plus omega cross vs. Keeping this relationship in mind, I am using this, and this is basically a type of acceleration. So but how vs is related to vr, means velocity in the s frame is related to the velocity in the r frame, how it is linked with each other, this we have derived here. So let us put the value of vs from here in this expression. So what should I do? So I can write down simply as the it is yeah, so it is dvs over dt in s frame is equal to d, its value will be vr plus omega cross r and whole dt plus omega cross, its value will be VR plus omega cross R. It is the value of this which I substituted from here and here, right? So what I am getting finally, it is dvs over dt in S frame is equal to dvr over dt. It is dvr over dt plus d upon dt omega cross r, because it is for the R frame. It is for, yeah, it is for R frame. So I can simply write down it like this. It is R frame plus omega cross VR plus omega cross R. It can be substituted like this. So let us do little more algebra. So what I am getting, it is dvs over dt, it is dvs over dt in the S frame is equal to dvr over dt in R frame plus, so now how it is written as, since omega is a constant because it is the uniform angular acceleration, so this can be written as, means d upon dt omega cross r, it can be written as omega cross dr by dt. So therefore I can write down it like this. So it is omega cross dr over dt in the R frame plus omega cross VR plus omega cross R. So what it will be, it is the VR, it is VR, this quantity is nothing but it is the VR. So therefore we are getting this relationship dvs over dt in S frame is equal to dvr over dt in R frame plus omega cross V. Two terms are like, so they can put together. So therefore was the relation which I am getting, and say this is the change in the velocity in the S frame, so it is known as acceleration in the S frame and it is equal to acceleration in the R frame plus 2 omega cross VR. It can be written like this, plus omega cross R. So acceleration in rotating frame, it can be written as acceleration is the stationary frame minus 2 omega cross VR minus omega cross R. So this is the required expression which we are getting. So what I am interested to find out the forces. So if I multiply mass on both sides, and the mass is an invariant quantity because we are in the non-relativistic limit, so therefore I can write down as the MAR is equal to MAS minus 2m omega cross R, sorry, not omega cross R, omega cross BR minus m omega cross R. So here this is the real force acting on the particle, right, when in the stationary frame, and it is the net force, and acting on the particle when it is in the rotating frame of reference, and these are the two additional components, these are they are acting on the it. And what these components will do, this is basically a, these two forces are the fictitious forces, and out of which this one force is basically, this force is known as the fictitious force, and it's a centrifugal force, and it is acting radially outward. So I will talk about these two forces later on. The first is the Coriolis force and another is centrifugal force, and I have shown these two forces to you, that and their effect on the motion of the particle when it is in the moving frame of reference. So I think that's all for this lecture. So here Coriolis force is represented by like this. It is 2m omega cross Vr. It is with the negative sign, and F centrifugal force is the minus m omega cross R. This is the centrifugal force, and it is acting radially outward. So in the next lecture I will talk about their nature and how these affects various things on Earth, because our Earth is also a rotating frame of reference and it is moving with a uniform rotational velocity. So I think that's all for this lecture.